So we've decided that we can solve quadratic equations by graphing, and we look for x-intercepts. So now quadratic equations can have no solutions, one solution, or two solutions. So we look at what the graphs would look like. We're looking for the x-intercepts in each of these graphs. So this is the case where there's no solution. This graph does not cross the x-axis, so there's no x-intercept, so there's no solution. Here, we end up with one solution because the graph, the vertex is on the x-axis, so there's only one solution here. And this is where we have two solutions. So this one solution, our solution would be x equals -2. And this one would be x equals -1 and 3. So if we think about solving this one by graphing, we first have to actually do the graph ourselves. So we have to first find the axis of symmetry. So x equals the opposite of b, -5, over 2 times a, which is 1. So x equals -2.5. So we haven't had axis of symmetry at this point that has been anything but whole numbers, but we can still do this, no big deal. So I'm going to put in here, eventually, an axis of symmetry at -2.5. So if I can grab this and move it, there we go, -2.5. And so now we need to find our vertex. And our vertex, we plug in the 2.5. I might need a calculator. Let's see how I do here with that one. We plug in the x value because that vertex is going to lie on here. So using my fancy calculatora, I'm going to plug in -2.5. So I'm not sure which just quit. Let's do 2.5 times 2.5. And imagine they were negative, and then we squared them. So we'd get 6.25 plus 5 times 2.5 is 18.75. And so then we have to subtract 7. And the vertex is negative, actually it was positive, wasn't it? 11.75. Yeah. 11.75. -2. Here is 10. Here's 11. Here's 0.75. Somewhere about right there. Okay, nice big point. Nice job. Okay, so now we need some extra points, x's and y's. So let's choose some nice numbers. Let's choose, let's do -1 and 0. I'm going to do 0 first because that's fun. So if I plug 0 into my equation, 0 squared plus 5 times 0, 0, minus 7, -7. So over 0, down -7. So across the axis of symmetry, exactly the same amount is a point here. Okay, and then -1. Plug in -1. -1 squared is 1, plus 5 times -1 is -5, minus 7. So this is -4 and 7, -11. Interesting. So that would be -1, -11. So -1, -10, -11. So right across the way here, not here, but over right there, it's at -11. And then we can draw in our fancy parabola. What I don't know yet is where it crosses the x-axis. So it's great that we graphed it with that many points, but darn it, it's not crossing yet. So let's grab some more points. What if I go to 1? Plug in 1. 1 squared is 1 plus 5 minus 7. That's 6 minus 7, negative 1. Over 1, negative 1. So it looks like that's 1, 2, 3 away. So we have to go 1, 2, 3 away. So now we're here. Still didn't cross the x-axis. I have to grab another one. Let's plug 2 in. So 2 squared is 4, plus 5 times 2 is 10. So that's 14 minus 7 is 7. 2 comma 7. Over 2, up 4, 7. So that's 1, 2, 3, 4. 1, 2, 3, 4. There we go. So if you look at this, and we finish actually our graph extending through these points. Again, this isn't a terribly great, there we go, way to do this because we're not terribly accurate. It crosses the x-axis here, so x must be between, and you can just do BTW, and that's negative 1, 2, 3, 4, 5, 6, and 7, negative 6 and negative 7, and between 1 and 2. And that's our answer. Not too fun. We need a better strategy.